Imagine a world so hot it could melt lead. Welcome to Venus, our closest planetary neighbor. Its surface averages over 465 degrees Celsius, 870 degrees Fahrenheit, making it the hottest planet in the solar system, even hotter than Mercury. Mercury, despite being closer to the sun, lacks an atmosphere to trap heat, so it cools dramatically at night. Venus, however, is wrapped in a thick heat-trapping blanket, making the entire planet a scorching oven, day and night. Spacecraft that landed there survived only hours before being destroyed by the crushing pressure and searing heat. The Soviet Venera probes sent back haunting images of a desolate, rocky landscape beneath an orange sky. Early astronomers once imagined Venus as a tropical paradise, but it's a furnace, a warning from planetary physics. Why is Venus, so similar in size and mass to Earth, so radically different? The answer lies not in its distance from the Sun, but in its atmosphere. Venus's story is a cautionary tale of a runaway process that turned a promising world into a wasteland. Understanding Venus's heat isn't just academic, it has profound implications for our own planet. The secret to Venus's Inferno is its colossal, suffocating atmosphere. Surface pressure is over 90 times that of Earth, like being a kilometer underwater. This atmosphere is almost pure carbon dioxide, a potent heat-trapping gas. Venus's clouds aren't water, they're droplets of corrosive sulfuric acid reflecting sunlight and giving Venus its brilliant appearance. But beneath that beauty is a world of hostility, where acid rain evaporates before reaching the ground. The dense CO2 traps heat with ruthless efficiency. Sunlight that penetrates the clouds is absorbed by the surface, which radiates it back as infrared. CO2 absorbs this heat, preventing it from escaping into space. The result energy is trapped, turning Venus into a planetary pressure cooker. Sunlight checks in, but it can't check out. This atmospheric prison drives Venus's relentless planet-wide heat wave. It's a permanent state of extreme global warming. Venus is the ultimate example of the greenhouse effect gone wild. On Earth, greenhouse gases like CO2 and water vapor trap enough heat to keep our planet habitable. But on Venus, this process spiraled out of control. Imagine a car in the sun with ever-thickening windows. The heat just keeps building. Venus may have once had oceans, but being closer to the sun, its water evaporated quickly. More water vapor meant more heat trapped, causing even more evaporation, a runaway feedback loop. Eventually the oceans boiled away. The intense heat released even more CO2 from the rocks, thickening the atmosphere further. The process fed on itself until Venus became a superheated, desolate world. It's a monument to a climate tipping point, a greenhouse that never closes. Venus shows us what happens when a planet's thermostat breaks. The less and small changes can trigger irreversible planetary transformations. It's a warning written in the clouds. Venus and Earth are often called sister planets, similar in size, mass, and composition, yet Earth is a haven for life, while Venus is a toxic inferno. The difference? Location and atmospheric history. Earth sits in the Goldilocks zone where water can exist as oceans. Our oceans and life locked carbon away in rocks, stabilizing our climate. Venus, just 30% closer to the sun, was too warm. Its water evaporated and its carbon stayed in the air. Both planets have similar total carbon, but Earth's is buried. Venus's chokes the sky. This highlights how fragile habitability is, a delicate balance of distance, geology, and atmosphere. Venus is the road not taken, a stark reminder that planetary climates can diverge dramatically. Our world's stability is not guaranteed. Studying Venus isn't just curiosity, it's a warning. Venus is a real-world example of the greenhouse effect pushed to the extreme. By understanding Venus, we refine our models for Earth's climate future. Venus shows how a planet's habitability can be lost. As we search for other worlds, Venus teaches us what to look for and what to avoid. Exploring Venus drives technological innovation, pushing us to new engineering heights. Most importantly, Venus reminds us that climate stability is fragile. Its fiery fate urges us to protect the delicate balance that makes Earth livable.